Hello friends, welcome back to the channel. Today in Kubernetes Day 9 series continuation, we are going to discuss another type of Kubernetes service, that is the NodePort service. So far we have already seen cluster IP services and we learned that cluster IP services are internal to the cluster. That means they work only inside the Kubernetes cluster and external users like browsers or clients outside the cluster cannot directly access a cluster IP service. And that's exactly where NodePort service comes into the picture. Just to highlight one important point before we go deeper, NodePort services are generally not used in real-world production-ready environments. They are mainly used for learning, demos, testing, or very simple use cases. Now let's discuss what is a NodePort service. A NodePort service exposes our application outside the Kubernetes cluster by opening a fixed or static port on every worker node. In simple terms, this is what happens. Kubernetes opens the same port on all worker nodes. External users can access the application using NodeIP:NodePort. There is no ingress, no load balancer involved here. It's direct access. Because of this behavior, NodePort services can be used to access web applications that are facing the internet, especially in demo or learning scenarios. Now, if we look at this diagram, you will notice that three ports are involved. First, the target port. The target port is the port inside the container. This is where your actual application is running. For example, in our case, React application is running on port 8082. So when traffic finally reaches the pod, it goes to the target port. Second, the port itself. The port is the service port inside the cluster. Our pods talk to the service using this port. This port is not exposed to the outside world. It works only inside Kubernetes. Think of it as the entry point of the service itself. Third, we have NodePort. The NodePort is the most important one for external access. This is the port that opens on every worker node. External users like a browser will access the application using NodeIP:NodePort. And NodePort must always be in the range of 30,000 to 32,767. Anything outside this range is invalid. So if we talk about how the traffic flows, so traffic flows from browser to NodeIP, then NodePort to service port, and then target port of the pod. So even though users hit the node port, the request still goes through the service and then finally reaches the pod. So you can remember it like this: node port outside the cluster, port inside the cluster, and the target port inside the pod. Alright, now let's understand how NodePort works step by step using a 3-tier application diagram. Imagine we have a Kubernetes cluster. It can be Kubernetes or OCP OpenShift cluster with two worker nodes. Let's say 192.168.0.1 is the IP address for worker node 1 and 192.168.0.2 is the IP address for worker node 2. Inside this cluster, both our front-end and back-end applications are deployed using deployments. And each deployment is running with 3 replicas. In our previous lecture of cluster IP, we saw how we created a cluster IP service called SEH backend service to access our backend microservice pods, which are SEH students pods. In the upcoming lectures, I will show you how the front-end pods access backend pods using services. So everything communicates cleanly inside the cluster. Now coming to the front-end application. Front-end applications are meant to display UI and they need to be accessed from the external world, like from a browser. This is where a NodePort service can be used. Using NodePort service, we can access the front-end application from external traffic. For example, through a browser using the worker node IP and a NodePort value, which is 30,005 in our case. But here is an important point. Because NodePort requires us to open ports on worker nodes, it is not secure, and that is why NodePort should not be used in real world or production environments. Now let's discuss the flow, how NodePort works. Let me break this down step by step very clearly. First, we create a service with type NodePort. As soon as we do that, Kubernetes automatically does two things. It creates a cluster IP service in the background and it opens a node port on every worker node. Now, from the outside the cluster, for example from a browser, we access the application using something like http:/IP address: port number. So what's happening here? The external request first hits the worker node, specifically worker node IP and node port, which is 30,005. Once the request reaches the worker node on 30,005 port number, Kubernetes takes over and routes the traffic internally. And internally, the request flows like this: from node port to cluster IP service to service port and then to pod in the target port. So even though we are accessing the application from outside the cluster, inside the cluster it still behaves exactly like a cluster IP service. The node port simply acts as an entry point that allows external traffic to reach the service. So we can say node port is best for quick testing, learning Kubernetes, debugging services, temporary access, not for production applications. For real world applications, we should use ingress plus cluster IP or load balancer service for cloud-based setup and route for OCP, which is OpenShift Container Platform. Alright friends, now let's do a quick demo. For that, let me take you directly to the Kubernetes cluster. So here we have one master node and one worker node, and both of them are in the ready status. Also, we already have a front-end deployment for our React application, which is SEH web app deployment, and which is currently running. Let me show you that also. kubectl get deploy pipe grep sh hyphen, and from the output we can see the deployment has two replicas. That means two pods of our front-end application are running. These replica values were defined in the deployment manifest file. Now, just like we created deployment replica set and a pod manifest in earlier session, we will again use a definition file to create NodePort type of service. So let me switch to Visual Studio Code. Here inside the Kubernetes playlist repository, all the service related manifests are organized under the day9 folder. Here I have created a new file called service-frontend nodeport.yaml. The high level structure of this file remains the same. Just like other Kubernetes objects, we still have 4 mandatory sections: API version, kind, metadata, spec. To get the correct service related information, we can always check from the cluster itself using kubectl API-resources pipe grep svc. And from here we know our object is service, short name is svc, API version is v1. Now let's update these values in our NodePort service manifest. API version v1, kind service. Under metadata we give the service name. Let's name it SEH Frontend NodePort Service. We can give labels here, but we don't need them right now, so we will skip that. Next comes the spec section, which is the most important part of the service definition. This is where we define how the service behaves, and this is also the section that differs based on the type of service. First we define the type of service. For that, type. As discussed earlier, service type can be cluster IP, node port, load balancer. Since we are creating a NodePort service, we set type as NodePort. In the port section, this is where we define all the port related information. -target port. Our application is running on 8082. Let's give it 8082. Port, again 8082, and NodePort. So target port is the port where application is actually running inside the pod. For our React frontend application, it is 8082. And this port, this is the port of the service object itself. We will also set it to 8082. NodePort, this is the port exposed on the worker node. we will set this to 30,005 for our SEH front-end service. So important points to remember here. Out of these, only port is mandatory. If target port is not provided, Kubernetes assumes it to be same as the port. If NodePort is not provided, Kubernetes automatically assigns a free port in the valid range of 30,000 to 32,767. And this ports is an array, so we use a dash under the port section. We can define multiple port mappings within a single service if needed. Now, one very important section is still missing. How does this service know which ports it should route traffic to? The answer is service discovery using labels and selectors. So let's copy the labels from our front-end deployment manifest, which is SEH web app deploy under day 8. And from here, the label is type is equal to SEH frontend. We copy this label and paste it into our service file under selector. Just like deployments, services also use selectors to identify pods. So now our service frontend NodePort.yaml file is completed. Since I am maintaining all manifests in GitHub, let me push these changes. For that, git add dot git -m NodePort definition YAML created and git push. Now back on the Kubernetes master node, I have already cloned the repository under /opt code repo Kubernetes playlist and go inside day 9. Here do git pull to fetch the latest changes and do ls. Our service frontend NodePort.yaml is available. From here, let me apply the service manifest using kubectl apply -f service frontend NodePort.yaml. We can see service is created successfully. Let's validate using kubectl get service, and here is the output. So as you can see, service is successfully created. Let's understand this output clearly. The service name is SEH frontend NodePort service. The type of service is NodePort. Kubernetes has assigned a cluster IP internally. And most importantly, under ports, we have 8082:30,005. Here 30,005 is the node port that is opened on the worker node, and 8082 is the service port, which ultimately maps to the target port on the pod. Now access this application from the outside the cluster, we need the worker node IP address. For that, kubectl get nodes -o void. So from the output, this is my worker node IP. Now let's go to browser and access the application. Worker node IP is the IP of the worker node, and the port is 30,005. Is the node port we configured in our service. And hit enter. As you can see, we are able to successfully access our SH students React frontend application using node IP :NodePort. This confirms that our NodePort service is working exactly as expected. Now let me also highlight an important downside of NodePort services. Here we are accessing the application using the node IP address. But the node IP can change, for example, when the node restarts, when the infrastructure changes, when nodes are recreated in cloud environments. Also, from a security perspective, NodePort opens ports directly on the worker node. This exposes the node to external traffic, which makes it less secure. So once again, I want to clearly repeat this. NodePort services are not recommended for production environments. They are great for learning Kubernetes, testing, debugging, but not for real production workloads. So that's all for today's session. We will continue in the next lecture. Don't forget to like, share with your friends and subscribe to the channel. Meantime, happy learning and I will see you in the next video.